In the last two chapters, we've been doing a lot of work with linear equations. And an equation is just a mathematical statement with an equal sign in it. So when we have an equation, we can graph it in a Cartesian coordinate plane by finding the points that satisfy the equation. So we're trying to find the points that make the equation true. So when we graph a linear equation, we get a line because the points that satisfy the equation form a line if we graph it in a Cartesian coordinate plane. And so the line is basically the set of all points that satisfy the equation. So for example, if we want to graph the line that represents this equation, 2x plus 3y equals 6, we just need to find a few points and graph them and then connect them. Now, we don't have to find every point on the line, right? We just have to find a few points, and it really only takes 2 points to form a line. But even though in this in this particular case, I just found the x and y intercepts, right? So all I did is I just looked at where does x equal 0 and where does y equal 0. So I can make a little table, and I can say, well, when x is 0, right, then this 2x becomes 0, and we get 3y equals 6, and so y has to be equal to 2. So now I know that the point 0, 2 is on my line. And when y is 0, right, if y is 0, then I just have, this whole term is 0, and all I have is 2x equals 6, which means that x is equal to 3. So now I know that the point 0 or 3 comma 0 is also on my line. And that's all I really need to since I know that it's the equation for a line, I can just connect those 2 points with a line, right? Now, every point on this line satisfies the equation, right? And this line goes on forever, right? Even though I'm only really showing a portion of the Cartesian coordinate plane, this plane goes on and forever in all directions, and also this line goes on indefinitely in both directions, in either direction. So that's a linear equality, right? A linear equation is a linear equality, right? So, and this line is the set of all points where that satisfy that equation. All right. So if we pick any point, on the line, it will satisfy the equation. So you can already see that I have 3 comma 0. If I plug that into my original equation, which was 2x, 2x, and in this case x is 3 for this particular point here, and y is 0, so 3 times 0, if I add that up, I get 6. So you can see that is that was our equation. Actually, maybe I can show that on there. Right? That was our equation. So this satisfies the equation because it makes the equation true. All right, same with all these other ones. 2 times 0 plus 3 times 2 equals 6, right? It satisfies the equation. I can take any of these points and plug them into the equation, and it'll create a true statement. So again, 2 times 6 plus 3 times negative 2, right? You get 12 minus 6, which is 6. So this equation, this particular point is on the line. So let's actually show that. So that would be here. So this is 6 comma negative 2. If we evaluate, if we evaluate the next point, 2 times minus 3 plus 3 times 4, what do we get? We get minus 6 plus 12, which is 6 again. So that point also lies on the line. So if I go to negative 3 comma 4, you can see here it is right here. It's on the line, negative 3 comma 4. All right. You already knew all of that. So let's take a look at some other points. Let's test some other points. Now, I wish I could make this all at once on the same screen, but we'll scroll back and forth. Let's test some other points. We're just going to put them into the equation and see what happens. So my equation is 2x plus 3y equals 6. So if I put in the values 2 times 5, I'm going to put in the point 5 and see what happens. 3 times 5. All right, so that's 10 plus 15 gives me 25. All right, that is not equal to 6, right? that is actually greater than 6, right? So let's show where we have that point. So that was the point 5 comma 5. So 5 comma 5. I think that's right here, right? 1, 2, 3, 4, 5. Okay, so this is the point 5 comma 5. All right. So that gave us a value that was greater than 6. All right, let's take a look at the next one. 2 times 7 plus 3 times 1 equals, what does that equal? Let's see, 14 plus 3, that gives me 17. Again, that's greater than 6. Where is that point? 7 comma 1. So 7 comma 1 is right here. 7 comma 1. All right, let's test one more point. I think there's just one more left. Oh, I guess there's a couple more left. Okay, so let's test a couple more points. Now we have negative 2, 4. Actually, let's find where that is. Negative 2, 4 is right here. Right? Negative 2 comma 4. That's right there. So if we test it, 2 times negative 2 plus 3 times 4, what does that give me? Minus 4 plus 12 is a positive 8, which is again greater than 6. Let's test one more. 2 times 2 plus 3 times 2. That gives me 4 plus 6 is 10. Again, I get that particular point gives me a value that's greater than 6. All right, so 2 comma 2 is right here. 2 comma 2. Now it turns out if I pick any point above this line, the line that represents 2x plus 3y equals 6, I try to plug it into that equation, I get a value that's greater than 6. Okay? All right, so anything on that half plane, right, where the line essentially divides the Cartesian coordinate plane into two parts. And in this half plane, any of those, if I evaluate any of those points using this equation, I get a value that's greater than 6. All right, so let's test some points on the other side of the line. Let's test these points. All right, so negative 5, negative 5. All right, so all I'm going to do is put it into my equation. Negative 5 plus 3 times negative 5. Now, obviously, this is something negative. It ends up being negative 25. Now, that's less than 6. Let's see where that point is. Negative, wait, what was it again? Negative 5, negative 5. So negative 5, negative 5. Assuming each one of these is 1. So negative 5 is down here. Negative 5 comma negative 5. All right. And we can test any of these points. 2 times 2 plus 3 times negative 1 gives me what? It gives me 1, which is again less than 6. Okay, so let me graph that point. 2, negative 1. So 2, negative 1 is right here. 2, negative 1. All right, so now you can see we're testing points in this lower half plane. And anytime, for any of these points, if I evaluate that function 2x plus 3y, at any of these points, I'm always going to get something less than 6. Okay, so here this one gives me 0. And if I evaluate the other one, the last one, 1 comma 1, that gives me 5. All of those are less than 6. Okay, so it turns out that if I pick any point, let's see, I had 1 comma 1, which is right here, just barely below the line, and I had negative 3 comma 2. Negative 3 comma 2 is here. Negative 3 comma 2. Any of the points that I pick, this one was 1 comma 1, in the lower half plane give me, when I evaluate 2x plus 3y, I get something less than 6. All right, so it turns out that that line, 2x plus 3y equals 6, divides the plane into two half planes. On one side, if I evaluate the function 2x plus 3y, I get something greater than 6. If I evaluate anything on the other side of the line, I get something less than 6. Okay, so that kind of sets the stage for how we can solve linear inequalities. All right, So that's just sort of an introduction, and I'll meet you in the next video for the first example.